All right, welcome to lesson 20. So we are picking up where we left off from lesson 19 in Math 0930. We're now in a new unit for Math 0931. And the topic that we're going to see here actually does relate to something you would have seen in Intermediate Algebra Part 1, where we first started learning about inequalities. So we learned about less than, greater than, less than or equal to, greater than or equal to. We also learned about interval notation. So those things will kind of come back in this topic, but we'll build on that. So compound inequalities, maybe think about the phrase compound sentences where you're joining two sentences together. A compound inequality is two inequalities joined by the word and or the word or. So here's the first type. The first type is called a conjunction. So conjunctions use the word and. The solution is the intersection or overlap of the solution set of each separate inequality. So for example, x is greater than -1 and x is less than 3. So what's graphed on here is two different number lines. The first one has this red arrow pointing to the right. So x is greater than -1. That represents all the numbers that are greater than -1. So they're to the right of -1 on the number line. And that arrow points to the right. This list goes on forever. Now the number line right below it, that represents the second inequality. X is less than 3. So this is a blue arrow. It's pointing to the left, starting at 3. So this represents all the numbers that are less than 3. So to the left of 3. Okay, but we only want the numbers that are both of those things. We want the numbers that are greater than -1 and less than -3. So what's down below this third number line, it's kind of shaded in purple. This represents all the numbers that are essentially between -1 and 3. So for example, let's say the number 0. 0 is greater than -1 and 0 is less than 3, right? It fits both of those descriptions. So it's included in the solution set. Another example might be, let's say, how about the number 5? 5 is greater than -1, but 5 is not less than 3. 5 is all the way over here on the right side. So it is not included in this final solution. Okay, so the solution set, again, is the numbers that are greater than -1 and less than 3. And visually what that looks like is the numbers essentially between -1 and 3. Another thing I'm going to do on the number lines here is you might kind of see these open circles around these numbers. With interval notation, which we'll review here in a minute, what we do is we actually represent that symbol with parentheses. So we're using parentheses to show that we're not including those numbers on the number line. There's no equal sign with our inequalities. So really my first number line, x is greater than -1, it has this parenthesis, but this sort of 1/2 of parentheses facing towards the right because we're going in that greater than direction. And then the next number line has the parentheses sort of facing toward the left. That would be x is less than 3. And then putting those together, we have these numbers in between -1 and 3. So here's how we would write the answer. Parentheses -1, 3. That is our answer in interval notation. And then set notation looks a little more complicated. Here's how I would say it. The set of all x such that -1 is less than x and x is less than 3. But what it really looks like is -1 is less than x, which is less than 3. What it also looks like is x sort of being in the middle or in between, there's that word again, between, in between -1 and 3. Okay, and what it really looks like when you write it out is sort of these squiggly brackets, that's called a set. Then there's x, then there's this straight up and down line. We usually say such that for that line. So again, the set of all x, such that, and then whatever comes after it is sort of a description of our set here. Okay, one last thing on this first slide, as you're getting used to all of this. We have what kind of looks like a Venn diagram, if that's something you've maybe learned about before. It's kind of these two different oval shapes. This first one in pink here is labeled with the letter A. The second one, kind of in this bluish color, is labeled with the letter B. And then what we're trying to show is where these two sets overlap each other. Okay, that's this sort of in-between spot where there's this shared space. So this is called the overlap or the intersection of two sets. You're not going to be drawing these diagrams really, but this is sort of another way to represent what's called a conjunction or an intersection. Okay, so when you see the word and kind of joining two different inequalities, the solution set has to only be what is true for both inequalities. Both need to be true. The numbers need to be in both sets. So with this other diagram, the solution set would represent this middle area only. All right, let's look at the next kind. So this next kind of compound inequality uses the word or, and that's called a disjunction rather than a conjunction. The solution set is basically the entirety of both sets. It's called the union or joining together of both solution sets, whether or not they overlap at all. So visually, here's this set A and set B again, but this time the union of two sets A and B is all elements belonging to A, B, or both. Okay, so here's an example with inequalities. X is less than 2 or X is greater than 8. So we want numbers that are in either one of those sets, or possibly both if it's possible. In this case, it wouldn't be possible for numbers to be in both of those groups. You can't be less than 2 and greater than 8 at the same time. That's not possible. So there's no overlap. So if the word and was in between, there would be no answer for this. There'd be no solution. But what we want is all the numbers that are either less than 2 or greater than 8. So visually on the number line, you can see there's two different arrows represented here. The first one, X is less than 2. We have this parentheses on the 2. The arrow is going to the left, and it does go on forever. I'm just going to label a little negative infinity symbol over here on the left, because that's technically the direction we're going for that first arrow. Meanwhile, on the right, the second inequality, X is greater than 8. It's an arrow pointing to the right with parentheses on the 8. And then this, again, this arrow is pointing in this positive direction. It goes on forever. It's going toward positive infinity. So that's what the number line looks like. In interval notation, here's what the answer is. Parentheses, negative infinity, comma 2, close the parentheses. Then here's this U symbol, which is called union. And then we have our second interval, parentheses, 8, comma infinity, and then close parentheses. This is our answer in interval notation. And something to notice is when you're naming interval notation, you can kind of go in the same order as the number line. Go from left to right. So notice if I read the number line left to right, the first thing is this negative infinity, then I put a comma, and then 2. Notice the parentheses on the number line is the same symbol I use in my interval. Then when I have a whole new set over here, a whole new inequality, and they're not touching each other, I need to show that I'm joining them together, and that's when this union symbol comes into play. It kind of looks like a U, but the sides are sort of straight up and down. Then parentheses, 8, comma, and then we do positive infinity. All right, good. And then for the set notation, we have the set of all X such that, now last time we had X in between two numbers, but that's not the case here. We don't want the numbers that are between 2 and 8. It's actually the opposite. We want them to be less than 2 or greater than 8. There's not really a shorter way to write that for set notation. We literally write the word or. So it's the set of all X such that X is less than 2 or X is greater than 8. And that's called set notation or set builder notation. And then one more time back up here with this other sort of Venn diagram again. The union of two sets A and B is all elements belonging to A, B, or both. Here's the symbol for that, A union B. It includes everything. Okay, so everything in set A along with everything in set B, including any overlap that they may or may not have. Okay, good. All right, so speaking of intersections and unions, here's some kind of different questions that we're gonna do pretty quickly, where we're practicing understanding the idea of what is an intersection and what is a union. So just to kind of remind us of what those things are, intersection, that's when we're going to include the overlap only. Whereas a union, that's when we include all of both sets. So I'm going to say include everything. Okay, so I just jotted down a couple of words up here. So intersections, we only include the overlap. Unions, that's when we include everything. So here's the first question. Find the intersection. And then there's these two different sets listed. The first set is A, B, C, D, E, F, G. Then we have this intersection symbol. It kind of looks like an upside down U or like a rainbow shape. Then the next set is A, E, I, O, U. So for the intersection, we want the overlap. What is in common? I'll write that down, in common. What do those two sets have in common? In other words, what letter or number is in both? So let's go through in order. I see the letter A. Is that included in both sets? Yes, it is. So for my answer, I'm going to draw a little squiggly here, and then I'm listing the letter A. Putting a comma. Is there anything else that's in both sets? How about B? That's in the first one, but not the second one. How about C? Same thing. D, same thing. Okay, what about, oh, here's one, E. E is another letter that's in both sets. How about F? No. And how about G? No. Okay, good. So I've gone through everything in this first set. The only elements that appear in both sets are the letter A and the letter E. So that's my answer. That's called the intersection. Okay, so that's what they have in common. Now let's look at those two sets again. This time, let's find the union. So this is where we're listing everything. So it's the same two sets, only this time we have this U symbol in between. Okay, now the trick here is, I'm gonna write down no repeats. So we are going to include everything, but if something does appear twice, once in each set, you do not want to list it twice. So let's go through that. Okay, so with union, I mean, I'm gonna list everything in the first set right away, A, B, C, D, and E. And now I'm gonna slow down when I go to my second set here, because remember, I don't want any repeats. So I see the letter A in the second set, but I already have it listed. So I'm not going to list it again. Same thing with the letter E. I already have it listed, no repeats, don't list it again. But then if I keep going, I, O, and U are not yet listed, so I will put those down. So here's the union between those two sets. A, B, C, D, E, I, O, U. That includes everything. We covered everything, but we didn't repeat anything, and that was finding the union between those two sets. All right, next question, two different sets. Okay, so this time we're finding the union of two different sets of numbers this time. The first set is 1, 2, 3, and the next set is 4, 5. So for union, we're gonna include everything. So I'll just list 1, 2, 3, 4, 5. And there were no repeats there anyway, so that one was nice and quick. Now for the last part, part D, find the intersection, the same two sets, 1, 2, 3, and then intersecting with 4, 5. So again, with intersection, we want the overlap. What do those two sets have in common? What's overlapping between them? And the answer is nothing. So there is no overlap here. They have nothing in common. So what we can write is this circle with a slash through it. That's sometimes called the empty set. And with inequalities, what we will sometimes have to say is no solution. Okay, so for example, if we wanted all the numbers that were less than 3 and greater than 4, there's no such thing. There's no such number that's included in both of those sets. So sometimes we say no solution. Okay, so again, with all 4 of these examples, With union, that's the U symbol. We include everything with no repeats. With intersection, that's sort of the upside down U symbol. We only include the overlap. We only include what the two sets have in common. If they don't have anything in common, that's when we say there's no solution. Okay. Eventually, we're going to be working toward solving compound inequalities. But before we get there, we need to do some review of interval notation. We've seen it a little bit already, but we're going to do a little bit more review here. So we have this chart that we're filling in. On the left side, we have these different compound inequalities where X is in between A and B. Then in the second column, we have interval notation, and we'll remember when to use parentheses versus square brackets. And then over on the right side, we have a place where we can kind of sketch a number line representation. So for the first one, we have X in between A and B. So it's A is less than X and X is less than B. Notice that there's no equal signs under the inequalities. So that's why we use parentheses for that one. So it's parentheses A, comma, B. Here's what the number line would look like. So A and B can just be any numbers in this example. So I'm just sketching a little number line. I'm putting A and B both on the number line. And we want to include all the numbers between A and B. Here's what that would look like, kind of as a sketch here. I'm going to use parentheses for both. They're kind of facing inward. And then we're shading in between. So look how similar it looks to the interval notation. We have parentheses, A, and then we're kind of shading, and then we end our parentheses at the B. All right, let's look at the next example. A is less than X, and X is less than or equal to B. Notice that equal to symbol. What's different now about interval notation is we have parentheses A, comma, B, but then we have this square bracket around the B. We always use square brackets whenever there's that equal sign symbol under the inequality. So here's what my number line would look like. I would label A and B. So here's A and B. This time, when I kind of shade on my number line, I would have parentheses at the A and then shade to the B, but then this time I'd have that square bracket symbol. So that's a little bit weird looking. So parentheses at the A and then square bracket at the B. And again, the square bracket is because of that equal sign under the inequality by the B. All right, third example, this one is similar. A is less than or equal to X and X is less than B. So this time we get to fill in the interval notation, A, comma, B. But this time our symbols are slightly different. This time we have this equal sign next to or underneath the inequality for the A. So we need to start with square bracket around the A, comma, B. And then this time for B, we don't have the inequality. So this time we'll have parentheses around the B. So it's square bracket, A, comma, B, and then parentheses. So it's kind of the opposite of the last example. And it really comes down to what kind of inequality you have, whether there's an equal sign or not. Okay, so on my number line, square bracket on the A, then shading, and then parentheses on the B. All right, one more example here. This time it's A is less than or equal to X and X is less than or equal to B. Since both of those have since both of those have the equal sign, with our interval notation, we use square brackets around both letters. So square bracket, A, comma, B, and then square bracket. On the number line, A and B, both of them would have a square bracket. All right, here, let's see. Sorry about that. I had some tabs popping up. Here we go. Okay, square bracket around the A, square bracket around the B, shading in between. There we go. Okay, so when we get to solving inequalities very soon, we will need to give our answers in interval notation and on a number line. All right, so we have some examples here of some compound inequalities. It says write each inequality in interval notation, then graph it on a number line. Number one is -2 is less than or equal to X and X is less than 5. So keep the numbers in this order, least to greatest. Notice the equal sign under the inequality next to the -2. So I'm going to use square bracket, -2, comma 5. Then with the 5, that one does not have an equal sign, so I'll have parentheses for that one. So that's the answer in interval notation. Then for the number line, I'm going to use those same symbols. Let's see, I'm labeling -2, -1, 0, 1, 2, 3, 4, 5. All right, and then pretty much the same symbols that we just used for interval notation, that's what we'll use on the number line. So I have a square bracket around the -2. Then I'll kind of keep shading until I get to the 5. Then I'll close it off with parentheses. All right, next example, number 2. This one's a little trickier, be careful. So it's 3 is greater than or equal to x, and x is greater than 0. Now here's what would sometimes happen for this one. This is wrong, but here's what you might see. Square bracket 3, comma 0, parentheses. This is wrong because it's out of order. 3 is not less than 0. 0 is less than 3. And once you start labeling it on a number line, hopefully you'll realize, wait a second, 3 and then 0 over here, what? That doesn't make sense. So we really need to make some adjustments here. Okay, let's rewrite this inequality in order from least to greatest. So when I rewrite this, here's what it's going to look like. 0 is less than x, and x is less than or equal to 3. So notice how it's the same inequality, but kind of just flipped around. Notice that x is still in the middle. Let's see. With the 3, see how that greater than or equal to is sort of opening towards the 3. So 3 is greater than or equal to x. That's really the same thing as saying x is less than or equal to 3. I know that's a little bit confusing, but put a number in its place, right? So for example, if 3 is greater than or equal to 2, then 2 has to be less than or equal to 3. It kind of works both ways. If I'm older than you, then you're younger than me. It's just another example. All right. And then for the second part, it's a similar situation. X is greater than 0. That's the same thing as saying 0 is less than x. So visually, hopefully you can kind of see what's going on there. We rewrote the inequality. I imagine that kind of like I'm picking it up and flipping it around. Okay, so all of that was to help us get set up for our number line. So now we can label it correctly. 0 should go towards the left, and then 1, 2, and then there's 3 on the right. So you don't want to get into a situation where you're numbering things all backwards and out of order. Okay, so let's see. X is between 0 and 3. There's no equal sign on the inequality next to the 0, so we'll start with parentheses on the 0. And then with the 3, that one had an equal sign, so that one will have a square bracket. So it looks like I just did my number line first here. That's often how I do these. So I had parentheses by the 0 and then square bracket by the 3, shading in between. The interval notation, that would be parentheses 0, comma 3, square bracket. Okay, so lots of symbols to get used to here, lots of details to keep track of for this section. Okay, finally, now what we're going to do is actually solve a compound inequality. All right, feel free to pause and take a little break if that was already a lot, and then note the time and come back. I'm just going to keep going here. All right, so we are now going to solve compound inequalities. So we're kind of going through these 3 main steps. We're solving for the variable, meaning getting the variable x by itself. We're going to give the solution in interval notation, and then we're also going to graph the solution on a number line. Okay, so for number 1, it's -3 is less than or equal to 2x plus 5, and 2x plus 5 is less than 7. Now off to the side, I did make a note. This is an and inequality. Okay, so technically it's 2x plus 5 is greater than or equal to -3, and 2x plus 5 is less than 7. I find that to be more confusing writing it like that. You know what I'm going to do is leave everything exactly how it is in the original problem. And what we're going to work on is trying to get x by itself in the middle of our inequalities. That's what I'm going to try to do. So I want my final answer to have x in between two numbers. That's what we're going for. You can't do this with every problem, but if the problem is already set up in this way with an expression with x in the middle, keep it there. Okay, so I've just kind of circled that expression in the middle, 2x plus 5. So if we're working on 2x plus 5 and trying to cancel things out and get x by itself, let's start by getting rid of the plus 5. Now, normally when you solve an equation, you might be told to, do something on both sides, right? But what we're going to do is actually subtract 5 3 different places, which is kind of a little bit strange. So we're subtracting 5 in the middle, and we're subtracting 5 on the left and on the right. So we're keeping things balanced. We're keeping the equations balanced, but there's kind of more than one equation going on at the same time. Okay, so notice how I subtracted 5 in the middle of the inequality, as well as on the left side, as well as on the right side. So there's kind of 3 different sides here. That might be something that you've never seen before. Okay, let's simplify each of those 3 parts. -3 minus 5, that's -8 on the left side. I'm bringing down this inequality symbol, that less than or equal to. Now in the middle, we just have 2x, because the 5 already canceled. Then we have less than, and then 7 minus 5, that's 2. So I have -8 is less than or equal to 2x, which is less than 2. Now my very last step to get the x by itself would be to divide by 2, right? I have this 2x. I want to get rid of the 2. So let's divide by 2. I'm doing it in the middle, which means I have to also do it on the left and the right. So I'm dividing everything by 2. So here's what we're left with. Let's see, -8 divided by 2, that's -4. So -4 is less than or equal to x, which is less than 2 divided by 2 is 1. Okay, so we did it. So we got x by itself in the middle of our inequality. So essentially x is in between -4 and 1. Now -4 has that equal sign under the inequality, whereas the 1 does not. So we solved for the variable. Now let's give the solution in interval notation. So interval notation. Here's what that will look like. I'll have -4, comma 1. Now let's be careful about our symbols. Again, because of that equal sign by the -4, let's put that with a square bracket. And then since there's no equal sign with the 1, we'll have a parentheses there. So it's square bracket, -4, comma 1, parentheses. That's my answer in interval notation. So we did that. And finally, we'll graph the solution on a number line. So I'll just label some points here. So -4, 3, 2, 1, and then 0. Here's 1, 2, 3, 4. Okay, so label as many numbers as you want to. You're going to have numbers or number lines to choose from on your homework. So you'll just need to select the right choice. Okay, so I want a number line where we're essentially shading in between -4 and 1. Because of the square bracket, because of that equal sign, I do want also a square bracket on my number line by -4. So I have square bracket by -4, and then parentheses by the 1 based on that inequality sign. So again, those symbols on the number line essentially match the symbols from my interval notation. Okay, so this is how I would recommend doing a problem like this. However, if you prefer to split it apart and write it in a different way, here's what that would look like instead. So if you're satisfied with this, that's great. I'm about to show another way to do it. So I'm going to clear the drawings on this slide and show you another way. If you're good with it, feel free to fast forward to the next problem. Okay, so here's another way to do this problem. I could essentially write it as 2 different inequalities. That's kind of what I was attempting to show over on the right side here. So here's how you would do that. Start with the first inequality. -3 is less than or equal to 2x plus 5, except I would prefer to write it like this. 2x plus 5 is greater than or equal to -3. So that's this one here. And here's the other one. 2x plus 5 is less than 7. So both of these are true. So we can solve them both separately. Then we will graph both answers on a number line, and we're going to see where they overlap. It's kind of like the red number line and the blue number line overlapping to purple and that on that first slide. So that's kind of the approach we can take here. Okay, so let's solve these. We'll start with the first one. 2x plus 5 is greater than or equal to -3. I'll subtract 5 on both sides. 2x is greater than or equal to -8. Divide by 2. X is greater than or equal to -4. So this is part of my answer. Now moving to the other inequality, 2x plus 5 is less than 7. Let's subtract 5 on both sides. 2x is less than 2. Then divide both sides by 2. Oops. X is less than 1. So here's the answer I'm getting. It's x is less than or equal to -4 and I might have said it wrong. X is greater than or equal to -4 and x is less than 1. So let's try to represent that on a number line. Okay, so I'm coming up to the top here to sketch this on a number line. Here's -4, here's 1. All right, so with my first inequality, x is greater than or equal to -4. Let's try that one first. Greater than or equal to -4. Okay, so square bracket. I'm just going to draw my arrow going way off to the right here. So I have a square bracket around the -4 and then arrow going to the right. That's not my final answer, but it's kind of part of my answer. But now I need to go to the second half of our answer here. And x is less than 1. So for x is less than 1, I have parentheses on the 1, and this time my arrow is going to the left. Okay, so what I want you to look at here is I have two different number lines kind of going in these different directions, but because this is an and inequality, I need to only include the intersection. In other words, I need to only include the overlap. So if you can see the number lines that we've just sketched, it's that in-between part that we need to include. So the square bracket on the -4 to the parentheses on the 1. That in-between part is the overlap. That is the true final solution, which brings us to our answer in interval notation. It would be square bracket, -4, comma 1, and then parentheses. So think about those two different ways that we just solved this. I still think keeping the x in the middle the whole time is probably the simplest way to go. But if you kind of followed along with this other way, that's fine. You have two different number lines, but because it's an and inequality, we need to only include the overlap for our answer. All right, very good. Let's move on to number 2. Here's another and problem. Now this one really is written as two different inequalities. And so we're going to have to leave it like that, which is fine. So let's solve both. And we'll just make a little note that we're going to be only using, we'll only be taking the overlap for our final answer. So I'm just going to make a note of that right here. Okay, so here's my first inequality. X plus 5 is less than 10. So let's solve for x by subtracting 5 on both sides. 10 minus 5 is 5. So we're getting x is less than 5. And now over on the other side, we have another inequality to solve. X minus 4 is less than -3. Let's add 4 to both sides. So we're getting x is less than +1. Okay, this is kind of a tricky one. Notice that both of the inequalities are less than. So we will be noticing our overlap, but the arrows will actually be going in the same direction for this. Okay, so it looks like we're dealing with the numbers 1 and 5. So I'll just label some numbers related to 1 or close to 1 and 5. Okay, So at first, when I solved this problem ahead of time, I actually just assumed, oh, we're shading in between 1 and 5. Parentheses 1, 5. But I was wrong. So if that's what you thought as well, pay attention. Here's what we're going to do. For the first inequality, x is less than 5. Let's start at 5 on the number line. Less than means we're going to the left, and we're going to use parentheses. So I have parentheses facing to the left, arrow going to the left from 5. That's the first inequality. Next, I have x is less than 1. So for that one, we're starting at 1 for my inequality. I'm putting parentheses on the 1. It's less than, so once again, I'm going to the left. Okay, so the overlap, it's actually not in between 1 and 5. It's going to the left from 1. So both of the arrows kind of are showing up in this area that's to the left of 1. So my solution set, my overlap is x is less than 1. It's a little bit strange, right? We were maybe expecting to go between 1 and 5, but in this case, the overlap is just all the numbers less than 1. So for my interval notation, how do I say x is less than 1? Well, there's no kind of left endpoint over here. Where are we going? Remember, we're going toward negative infinity. So it's actually negative infinity, comma, 1, and then parentheses. And my final answer on the number line, if I had to shade it more darkly to really fill in my final answer, it would be this arrow from the left of 1 with the parentheses. So my interval notation is negative infinity, comma 1 with parentheses around both. We always use parentheses around infinity. Okay, and then my number line answer is just the arrow going from 1 to negative infinity with that parentheses. So I found that one to be a little bit trickier because usually with and problems, we look for overlap and it's usually in between two numbers, but in this case, both arrows are going in the same direction. Okay, a little bit tricky. All right, let's see what's next here. What we're gonna see next, yeah, we're almost done. What we're gonna see next is an example of an OR problem. Okay, so with the OR inequalities, what's going to be different here is instead of looking for overlap, we're going to be taking the union of both solution sets. They may or may not overlap, we'll see. Okay, oh, and it looks like I numbered my questions wrong. This should be number 3, sorry about that. We already did number 2. Yeah, number 3, my mistake. Okay, so here it is. Both of these involve some fractions, so that'll be good review. The first inequality is x plus 6 over 4 is greater than 1. And then the second inequality, or it's 2x minus 1 over 5 is less than negative 3. Okay, so notice that we have, in both cases, we have 2 terms in the numerator of a fraction. All right, so let's clear those fractions. Let's start with the first inequality. It's x plus 6 over 4 is greater than 1. Let's just get rid of that denominator of 4. So let's multiply both sides by the denominator. We can multiply both sides of the inequality by 4. The 4 will cancel out. It's essentially like 4 over 1, right? So that 4 in the numerator will cancel out the 4 in the denominator. And then the fraction's gone. So much easier now. Okay, so now instead of x plus 6 over 4, now we have just x plus 6. Greater than, and then on the other side, we had to do 1 times 4, which is 4. Then we'll subtract 6 on both sides. So we get x is greater than negative 2. Okay, we'll come back to that when we're done solving both, and we'll be sketching both of these on the number line. Let's solve the other one, or the other half. So it's 2x minus 1 all over 5 is less than negative 3. So similar way to start. Let's cancel out the fraction. We'll multiply both sides by 5. That cancels out the denominator. This is sometimes called clearing the fraction. And then we're left with 2x minus 1 is less than negative 15. So let's work on solving for x. We'll add 1 to both sides. So we have 2x is less than, and then negative 15 plus 1 is negative 14. Then divide both sides by 2. X is less than negative 7. Now it didn't come up in this problem, but I just want to remind you, if you ever divide by a negative number, you would need to flip the direction of your inequality. So a less than would become a greater than. That will probably come up on your homework. Just wanted to warn you about that. Okay, so here are the two different parts of our solution. We have x is greater than negative 2, or x is less than negative 7. Now, I don't think there's going to be any overlap, but even if there was, we would need to use that union symbol to join both inequalities together, whether or not they overlap. Now, let's be careful about numbering on our number line. Negative 7 is further to the left than negative 2. So negative 7, negative 6, 5, 4, 3. Here's negative 2, negative 1, 0, 1, 2. So I'm just labeling my numbers in order on my number line. Let's start with the x is greater than negative 2. So greater than means we're going to the right from negative 2. I'm going to use parentheses opening towards the right and my arrow going towards the right. That's the arrow for my first part of my inequality solution. Then the other one, x is less than negative 7. So I have parentheses on the negative 7, but this time they're facing to the left because I'm going to the left in that less than or negative direction. Okay, so notice on the number line, if we read our number line from left to right, here's how we would name our answer in interval notation. For this green arrow going to the left, remember it's going toward negative infinity. So feel free to label that on your number line as a reminder. And while we're at it, let's just also label positive infinity on the other side because we're going to need that. Okay, putting it all together in interval notation. Here we go. So parentheses, negative infinity, comma, negative 7, close the parentheses. Now we use the union symbol in between, and then we name our other interval, parentheses, negative 2, comma, infinity, close parentheses. This is my answer in interval notation. Okay, so again, it's negative infinity, comma, negative 7, close parentheses, union, parentheses, negative 2, comma, infinity, close parentheses. On your homework, there will be a button you can click on to use that union symbol. All right, so we've come to the end of our notes for lesson 20 on compound inequalities. I'm sure there's other types of problems on the homework. We haven't covered every single possibility, but I think you have the basics for now. And remember, we're meeting live over Zoom once a week for our class. So that's where you can bring any questions that you have. If there's anything that you don't understand from this video or any of the other videos. Okay, I think that's it. So good job making it through lesson 20, and I will see you soon for lesson 21.